एही कार्यक्रमर सह प्रायोजक हेले
Good afternoon, students. In the previous class, I was discussed the quadratic polynomial. Quadratic polynomial. What is quadratic polynomial? Quadratic equation and roots of the quadratic equation and the relation between the two roots and its coefficients. And also I had discussed nature of the roots. Nature of the roots, I have already discussed nature of the roots. I have already discussed 2 points regarding nature of the roots. So, first one is I have already explained you in the previous class. I have already explained you in the previous class. If d greater than 0, then roots are real and distinct. I have already discussed in the previous class here. If d greater than 0, then the roots are real and distinct. And also I have told you that if a, B, C belongs to Q and B square minus 4AC is a perfect square here, then the roots are rational and the roots are rational and unequal. If again I will explain the same case, second point I have already explained you. In the second case, if ABC belongs to Q, if ABC belongs to Q and B square minus 4AC here, which is not a perfect square, then the roots are irrational and unequal. So, today I will discuss more about the nature of the roots. The first is, the third point is, here I have already discussed the first and second point. The third point here is, if d equal to 0 dear, this is the very important case. If d which is equal to 0 dear, here you see, then roots are real and equal dear. Here the values are equal. You see, if alpha which is equal to minus b plus square root of b square minus 4ac divided by 2a and beta which is equal to minus b minus square root of b square minus 4ac divided by 2a. Here you see, d which is equal to b square minus 4ac, that means here the value of d which is equal to 0, then here you see alpha which is equal to minus b by 2a and beta which is equal to minus b by 2a, that means it has equal roots. This part is equal to 0 and this part equal to 0, then the value of alpha which is equal to minus b by 2a and the value of beta which is equal to minus b by 2a dear. That means if d is equal to 0, then the roots are real and equal. Here that value is equal dear. I will solve one question regarding this. Here you see, if d greater than 0, then the roots are real, but here that value is distinct, different or unequal. If d equal to 0, then the roots are real and equal dear. So, I will solve one question regarding this. Right, that question, for what value of t the equations x square minus tx plus 64 equal to 0 and x square minus 8x plus t equal to 0 has real roots dear. So, for what value of t the equations x square minus tx plus 64 equal to 0 and x square minus tx plus t equal to 0 has equal roots. I have already explained you, if real root means we can write this as a, if this one with the real roots, real root means if d greater than or equal to d greater than or equal to 0, then it has real roots. Here you see these two are the quadratic equation. If d greater than or equal to 0, then only it has real roots. That means these two are the two quadratic equation. If you consider, let d1 and d2 be the roots of the quadratic equations dear. Here you see d1 for the first equation and d2 for the second equation. That means here we can write this as a d1. So we know that if d1 is greater than equal to 0, then it has real roots, and d2 is greater than equal to 0, then it also has real roots. Therefore, we know that d square d1 is equal to b square minus 4ac, which is greater than equal to 0. Here you see in the first quadratic equation dear, here the value of a, here in the first equation, here you see from equation number 1, here from the first equation, what will the value of a equal to 1, b equal to minus t, and c equal to what? 64. Therefore, we can write this as a b square, means we can write this as a t square minus 4 into 1 into 64 dear. This greater than or equal to 0, t square minus, and this value is equal to 256 is greater than or equal to 0. Then here you see, then t square is greater than equal to 256 dear. Or here you can write this as a, here you see what will be the value then, here you see this big value is equal to 256, then we can write this as a mod t is greater than or equal to 16 dear. This value is equal to mod t is greater than or equal to 16. That means here you see t is greater than equal to 16 or t is less than or equal to minus 16 dear. We know that from the previous class, we know that t mod is greater than equal to 16, then only that t is greater than equal to 16 or t is less than or equal to minus 16. Here you see in the second case d square, again b square minus 4ac is greater than equal to 0. Here you see in the second case, in the second equation, what will be the value of a equal to 1, and what will the value of b which is equal to minus 8, and what will the value of c is equal to what? T. So here you see, if you substitute these values, minus 8 square is 64 minus 4 into 1 into 2 greater than equal to 0 dear. So 64 minus 40 greater than equal to 0, or we can write this as a 64 greater than or equal to 40. So if you divide these two, 16 is greater than or equal to t, so that value is t is less than or equal to 16. Here you see all of you, here you see in the first case the value of d is greater than equal to 16 or t is less than equal to minus 16, but in the second case here you see t is less than or equal to 16 dear. That means from these three relations you see, then which one is the common one? Which value is the common one? Here that value of t is equal to 16. Here you see here t equal to 16, here also t equal to 16, and here t is equal to minus 16. So which value is the common one? The value is t which is equal to 16. Okay. So this is all about if the two equations are given and these two equations has real roots. That means if these two equations has quadratic equation has real roots, I have already know that the d must be greater than or equal to 0. If d greater than 0, no doubt the roots are real and distinct. If d equal to 0, then the roots are real and equal. In both the case, the roots are real. Therefore, we can write this as a d greater than equal to 0. Here you consider these to be the two quadratic equation. Therefore, d1 and d2 be the roots of the, or we call it as a these two be the discriminant of the quadratic equation. You call it as a discriminant of the quadratic equation. So, d1 is equal to this value, t greater than equal to 16 and t less than equal to minus 16. So, the common value t which is equal to 16 dear. Next, in the nature of the roots, fourth point, in the nature of the roots dear, this part is the important part, basically that is used in the 11th class. Here you see the fourth one is, I have already told you, if d is greater than 0, then the roots are real and equal. If the roots equal to 0, then roots are real and equal. Here you see, if d is less than 0 dear, then it has no real roots. It has no real roots. Here you see, we know that this discriminant, here you see, the value of x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a dear. That means, if d less than 0, if the value of d is less than 0, that means if this is negative value, for example, if x is equal to minus 2 plus or minus square root of minus 3 divided by suppose 4. Here you see minus 2 plus or minus square root of minus 3 divided by 4. How to calculate square root of a negative number? Because this is, here this one with a real, it has no real roots dear. So, it has no real roots, but the important part is it has imaginary roots, or we call it as a, this has complex roots. Here you see, it has no real roots, but that important point is the star mark for important point, it has imaginary roots dear. It has imaginary roots. See, it has imaginary roots, or we call it as a complex roots. That means imaginary, or we call it as a complex roots. That means how to calculate the square root of a negative number dear. So, if you calculate the square root of a negative number, then it forms a either an imaginary number, or we call it as a complex number, but it has no real roots, but it has complex roots, it has imaginary roots. Therefore, the great mathematician Euler introduced this symbol dear, introduced this symbol I, that is for iota, it is known as iota, and that symbol for, listen, very important one, the great mathematician Euler introduced I, the symbol I, iota, that is known as iota, which is equal to square root of a negative number dear. That means here you see I equal to square root of minus 1. That means here you see, if you squaring on both the side, then this value is equal to, dear you see, I square value is equal to what? Minus 1. That means that I is an imaginary number. I is an imaginary number. You see some example. Suppose if you solve one question, solve x square plus 1 equal to 0. X square plus 1. So, I will take a break. After break, I will continue. हाँ, let us start. हाँ, hello. हाँ, देखा ठीक है तो जो क्वेश्चन पचार थला, if 2x square plus kx plus 3 equal to 0 has the equal roots, that means here you see dear, a equal to 2 and b equal to k and c equal to 3 dear. If it has equal roots, then d which is equal to 0 dear. Therefore, we know that b square minus 4ac which is equal to 0. Here the value of b is equal to k square, 4 into 2, a is equal to 2 and c equal to 3, this equal to 0. Therefore, k square minus, here you see dear, 4 into 2, 8 into 3, 24. So, the k square which is equal to, you can write this as a 24, or we can write this as a k which is equal to plus or minus square root of 24, or we can write this as a plus or minus 2 root 6 dear. Then the value of k is equal to plus or minus 2 root 6. Okay dear?
Yes, sir.
Okay. Hello?
Next here is 7x square minus 9x.
7x square minus 9x.
7x square minus 9x plus 2 is equal to 0.
0.
समीकरणर मूलद्वय स्वरूप कौन हम?
कौन हम क्वेश्चन आउ थे कहल? क्वेश्चन आउ थे कह. हाँ देख ताकू जदि आमे केते मेथड अछि आकु सॉल्व करिया पई आकु आमे फैक्टराइजेशन मेथड रे करि परिबा. वी हैव टू सॉल्व बाय यूजिंग द फैक्टराइजेशन मेथड और बाय यूजिंग द डायरेक्ट फार्मूला. वी नो द वैल्यू ऑफ अल्फा एंड बीटा. यू सब्स्टिट्यूट दिस वैल्यूज एंड फाइंड द वैल्यू, और you use here you see 7 into 2 is dear 14x square. So instead of 9x we can write this as a minus 7x minus 2x plus 2 equal to 0 dear. From the first two term taking out common as 7x, rest is x minus 1. Again from these two term taking out common as minus 2, rest into x minus 1 equal to 0. So 7x minus 2 into x minus 1 equal to 0. That means either 7x minus 2 equal to 0. So the value of x equal to 2 by 7, or x minus 1 equal to 0, then the value of x is equal to 1 dear. That means this is a quadratic equation, so it has two roots. Then one root is x equal to 2 by 7 and the other root is x is equal to 1 dear. Okay? बुझी पारलो? हाँ देख एबे टिके आमे जो कथा एबे मु तुमको कहूतिली आगुरु देख एडी. How to calculate the square root of a negative number dear? How to calculate the square root of a negative number? The great mathematician Euler introduced I, the symbol I, this is known as iota, which is equal to square root of minus 1. That means the value of I square is equal to minus 1 dear. Here you see one example. X square plus 1 equal to 0 dear. This is a quadratic equation. This is a quadratic equation, but here you see this has, I have already told you, if d less than 0 it has no real roots, but it has, hello?
Hello, sir. Namaskar.
हाँ को तुम कौन क्वेश्चन अछि?
Sir, I have a doubt.
हाँ को कौन टा क्वेश्चन टा को?
A peacock is sitting on a
कौन टा?
pillar 9
हाँ क्वेश्चन आउट के लाउडली को सुबुनी.
A peacock is sitting on a pillar 9 cubits high. A snake at a distance of 27 cubits from the pillar is coming to a hole at the base of the pillar.
क्वेश्चन टा क्लियर होनी टिके. क्वेश्चन टा क्लियर होनी रे. हाँ कौन कोजो टा क्लियर होनी. हेलो क्वेश्चन टा कहीं क्लियर होनी टिके. Okay, here you see one example. If x square plus 1 equal to 0, here you see x square which is equal to dear minus 1. So this is a quadratic equation. So it has two roots. If x square is equal to minus 1, here you see x square is equal to, instead of we can write this as a minus 1 which is equal to I square dear. That means this value is equal to I square. So here you see if x square is equal to I square, then automatically the value of x is plus or minus I. Here you see it has two roots, but one root is I and the other root is dear minus I. That means it has imaginary roots, and here you write, and the roots are conjugate to each other, conjugate to each other. What is the meaning of that conjugate here? That means if one root is plus I, then automatically the other root is minus I. It has, this is also a quadratic equation, but it has two roots. If one root is plus I, then the other root is minus I, dear. Here you see. So I explain the next complex number. I will explain you the complex number. In the beginning, I have told you the quadratic equation ax square plus bx plus c equal to 0. A, B, C belongs to a real or complex. I have already explained all the relations of the real number, but I will explain you what do you mean by complex number, dear. Complex number. Complex number. Here you see complex number. That number, what do you mean by first complex number? A number is of the form z, which is equal to a plus ib, dear. Here you see that z, it is denoted by z, which is equal to a plus ib, where a and b belongs to real number, and that I means iota is equal to square root of a negative number, that is minus 1. I, which is equal to square root of minus 1, is called complex number, dear. This is called complex number. Here you see, that means here you see z, which is equal to a plus ib, dear. That means here a, that part a is known as real part of z. Z denoted as a complex number. This part we call it as a part को हमें कौन कहती है एटाको ना real part of z. And the second part जोटा अच्छी देखु था ये जो b part को और it is denoted as को हमें लिखी पारंती re of z means real part of z. Similarly, b, that b is known as the imaginary part of z, or we write this as a imaginary of z. B is imaginary of z. Here you see the complex number which is in the form of a plus ib. Why I will discuss this? Because we know that in case of a quadratic equation, if d is less than 0, then it has a complex root. If that complex root is conjugate to each other, that means if one value is equal to I, then the other one is minus I. Same case here, dear. If one value is equal to a plus ib, then other root must be a minus ib. That a minus ib, we call it as a conjugate of a complex number. Next we can write this as a conjugate of a complex number. Conjugate of a complex number. Here you see, dear, conjugate of a complex number, conjugate of a complex number is denoted by z bar. Dear, here you see, this is denoted as z bar. If z is equal to a plus ib, then automatically z bar is equal to a minus ib, dear. That means if in case of if a, b, c be the real root and d less than 0, very important point, if d less than 0, then it has no real roots, but it has imaginary or complex root, and that complex root is conjugate to each other, dear. If one value is I, then the other one is minus I. Same case here. If one root is a plus, suppose one root is 2 plus I root 3. This is a complex number. If one root, that is alpha, is equal to 2 plus I root 3, then the other root must be 2 minus I root 3. If, very important part, if a, b, c belongs to a real number and d, that discriminant is less than 0, the discriminant less than 0, then alpha which is equal to 2 plus I root 3 and beta is 2 minus I root 3. That means these two values are conjugate to each other. I will solve one or two questions so you better understand. First one is solve. Here you see 4x square plus 9 dear which is equal to 0. Here you see 4x square plus 9 equal to 0. So, this is a quadratic equation dear. Here the value of a is equal to 4 and the coefficient of x, that is b, is equal to 0. So, first you write given 4x square plus 9 equal to 0. I solve it in two ways, first by using the factorization method or by using the direct formula. You see all of you, 4x square plus 9 is equal to 0. So, here you see 4x square, instead of plus 9 we can write this as a dear 9I square. Okay. If you write this 4x square which is equal to minus 9, if you write like this 4x square which is equal to minus 9, then x square which is equal to minus 9 by 4, then x which is equal to plus or minus square root of minus 9 by 4, it creates problem. So, you solve like this, like factorization method. That means instead of plus 9 we can write this as a minus 9I square, because I have already explained you here that value of I square is equal to minus 1. Therefore, we can write this as a minus 9I square. So, this value is equal to, here you see 2x whole square minus 3I square is equal to 0. Here you see this part is equal to 9I square. So, you can write this as a 3I whole square. Again you see this of the form, which is of the form a square minus b square which is equal to 0. So, you can write this as a 2x plus 3I into 2x minus 3I equal to 0 dear. Here you see. So, it has, this is also a quadratic equation, it has two roots. So, either here you can write this as a either 2x plus 3I equal to 0. So, you can write this as a 2x is equal to minus 3I, x is equal to minus 3 by 2 I. Here you see this value is equal to minus 3 by 2 I, and the second value is 2x minus 3y equal to 0. So, 2x equal to 3y dear. So, x is equal to 3 by 2 I. Here you see, if one root is 3 by 2I, then the other one is minus 3 by 2I. That means here the roots are 3 by 2I and minus 3 by 2I, and these two are conjugate to each other. Here that means we call it as a, we can write this also as a 0 plus 3 by 2I. So, which is in the form of a plus ib or bi. We can write this as a plus ib or bi. That means here the real part is 0. Similarly, in the set, hello.
What is difference between complex number and conjugate complex number?
The difference between the complex number and the conjugate number is, here you see dear, if a plus ib, this is I have discussed z which is equal to a plus ib, then a conjugate of a complex number is only, instead of that plus we can write this as a minus ib, only change the imaginary part, that is the imaginary part, and this part a be the real part and that part be the imaginary part, only the imaginary part change. If you give an example, if z is equal to 2 plus 3i dear, if z which is equal to 2 plus 3i, then automatically the conjugate of z is 2 minus 3i. If question again arises, if z is equal to minus 2 plus 3i, suppose minus 2 plus 3i, again the conjugate of a complex number is minus 2 minus of 3i, only change the imaginary part. In the first case this one be the plus, in the second case conjugate case this one be the minus. বুঝি পারল? Okay. Next question, here you see these two roots are conjugate to each other. Next I will solve one more question, number 2. Number 2 dear, solve question is solve x square, question is solve x square minus 4x plus 13, x square minus 4x plus 13. Okay. So here you see, first you check here, dear you see a equal to 1, b equal to minus 4 and c equal to 13. That means this is a quadratic equation with real coefficients. So automatically first you have to check, here you first you write given x square is minus 4x plus 13 equal to 0. Here you check a equal to 1, b equal to minus 4 and c equal to 13 dear. So we know that if the discriminant, first we have to check if the discriminant is less than 0, then it has imaginary roots. Either you use the factorization method or you use direct in the formula, then you get the required result. Here you see the discriminant means b square minus 4ac dear. B square means minus 4 square is 16 minus 4 into 1 into 13. Here you see 16 minus this value is 52. So 52 and 16, 6, this value is equal to minus 36 dear. That means that value is less than 0. If that d value is less than 0, so automatically it has imaginary roots, or we call it as a complex root. So how to solve this complex root? By factorization method, by factorization method, or you use by using the formula, you can solve it. Next you solve by factorization method. Here you see here the first part, here you see x square minus 4x. So we have to convert this part in a completion square. I have already explained you, we have to convert this part to a completion of square. That means here you can write this as a x square 2 into x. Here you see we have to convert. In the first class I have already discussed you, we have to convert. Here a, capital A is equal to x, here b is 2. That means here you can write this as a plus 4 minus 4 and plus 13 equal to 0 dear. Here you see x square, first we have to convert this part to a completion of square. That means we can write this as a x square minus 2 into x plus 4 minus 4 plus 13 equal to 0. So from the first part you see x minus 2 whole square plus 9 minus 4 plus 13, or directly you can write, if you add plus 4 then only you can write 9, because this value is equal to 13. No necessary to write minus 4 plus 9, we can write this. So this value is equal to 0 dear. We have to solve this x minus 2 whole square plus 9, x minus 2 whole square plus 9 which is equal to 0. Here you can write this as again x minus 2 whole square plus 9. That means we can write this as I have already explained in the previous question. Instead of plus 9 we can write this as a, already I know d less than 0. So it has imaginary root, automatically that plus 9 can be converted to minus 9i square which is equal to 0 dear. Here you see, that means we can write this as a x minus 2 whole square minus 9i square is equal to 3i whole square dear. Here you see I square, that value of I square is minus 1. So this one equal to plus 9. So x minus 2 whole square minus 3i square is equal to 0. Again, which is in the form of a square minus b square equal to 0. We know that a square minus b square which is equal to a plus b into a minus b. That means here we can write this as a x minus 2 plus 3i dear. This is one part, and the second part is x minus 2 minus 3i which is equal to 0 dear. Here you see again, either this part is equal to 0 or this part is equal to 0. That means either x minus 2 plus 3i equal to 0. So x is equal to, here you see 2 minus 2 go to the right hand side, 2 minus 3i, x is equal to 1 root is 2 minus 3y. Automatically you see the other root be 2 plus 3y. Here you see the second case, x minus 2 minus 3i which is equal to 0. Here you write this as a x is equal to 2 plus 3i dear. Here you see. Therefore, I have discussed you the what is complex number and what is the conjugate of a complex number. So, it is easier to understand this. Here you see one root is 2 plus 3i and what will be the other root? 2 minus 3i. If that means here the roots are 2 plus 3i and 2 minus 3i. So, automatically this is a quadratic equation. So, it has 2 roots dear, and that 2 roots is one is 2 plus 3i and other one is 3 minus 2 minus 3y. Therefore, these two are the conjugate of a complex number. So, I have already discussed in the quadratic equation a, b, c are real. This is all about if a, b, c are real. I have already explained in the first class if a, b, c are real or complex. If a, b, c be complex, then what will happen? Next is quadratic equation with complex coefficients. Next is, see here, quadratic equation with complex coefficients. Quadratic equation with complex coefficient. I have already discussed the real coefficients. Next is quadratic equations with complex coefficient. We know that the quadratic equation which is in the form of ax square plus bx plus c equal to 0 and a which is not equal to 0, and here you write and. That is the important part here. A, b and c, a is not equal to 0 and a comma b and c be complex number dear, be complex number, then this equation we call it as a quadratic equation with complex coefficient. Here a, b and c be the complex number. Same formula you write this important note here. The same formula for quadratic equation with complex coefficient. I have already explained in case of a real coefficient the how to calculate or how to find the roots of the quadratic equation. Same case in case of a complex coefficient. Then what will be the formula here? X is equal to, I have already explained this one, minus b plus or minus square root of b square minus 4ac divided by 2a dear. Here that means it has also two roots. That first root is minus b plus square root of b square minus 4ac divided by 2a. Next, the second one is the important one. This second is important one. Here you know b square minus 4ac is equal to the capital D, and that capital D is known as the discriminant of the quadratic equation. Here if D is equal to 0, then it has complex roots. It has complex roots, and it has, here you see, it has complex roots and are equal. Here you see, and are equal. In case of a quadratic equation with real coefficient, if D equal to 0, then it has a real roots. Hello? हाँ को कौन तम डाउट अछि
sir x plus 1 by x is equal to 2 cos theta.
x plus 1 by x is equal to 2 cos theta dear.
So that x to the power n plus 1 by x to the power n
equal to,
hello,
हाँ को is equal to
x to the power n plus 1 by x to the power n is equal to 2 cos n theta.
n theta dear. Okay, you will ask this question. This is regarding to the complex number question dear, but this is used in case of a De Morgan's theorem. I know you know that in case of a De Morgan's theorem, I will explain you. Let x plus, here you see this is a complex number, this one is 1 by x is the conjugate of a complex number. If a complex number, let x is equal to suppose cos theta plus I sin theta, and 1 by x is equal to automatically, this is a complex number, here you see cos theta plus I sin theta, 1 by x is conjugate of this complex number. That means we can write this as a cos theta minus I sin theta. Here you see you have given condition is x plus 1 by x is dear 2 cos theta, x is cos theta plus I sin theta, and 1 by x is cos theta minus I sin theta. If you add these two terms, see it, if you add these two terms, then this equal to 2 cos theta, okay or not? Again here you see in the De Morgan's, the great mathematician De Morgan explained you that is cos theta plus I sin theta dear whole to the power n. N belongs to the integer, we call it as a n belongs to an integer. So cos theta plus I sin theta whole to the power n, that is equal to cos n theta plus I sin n theta dear. Okay, same case here you see. Here this x is equal to this one. So what will be the value here? Cos n theta plus I sin n theta. If 1 by x means this value is equal to minus. So here you can write this as a left hand side x to the power n 1 by x whole to the power n. Here you see x to the power n, instead of 1 by x to the power n we can write this as a 1 by x whole to the power n. That means here x to the power n, here you see x equal to cos theta plus I sin theta, x to the power n is equal to cos n theta plus I sin n theta dear. Again here you see 1 by x whole to the power n, here you see 1 by x whole to the power n. By using the De Morgan's theorem we can explain it as a cos n theta minus I sin n theta. Okay, here you see this sin n theta, I sin n theta and I sin n theta cancelled here, and what will be the value? Cos n theta plus cos n theta, this equal to 2 cos n theta. বুঝি পারল? দেখো देखो तुमको एवं जो कथा कहूली थर्ड सेकंड पॉइंट रे if d is equal to 0, if in case of a complex coefficient if d is equal to 0, then it has complex roots and are equal. That means here that two values alpha and beta means minus b plus square root of b square minus 4ac divided by 2a. If d is equal to 0, then x is equal to minus b by 2a. Again in the second case is x is equal to minus b by 2a. That means it has the roots are equal. Third one is in case of a complex coefficient here, if d is not equal to 0, then it has complex roots. Very important point this one. If d not equal to 0, then it has complex roots and are unequal here, and are complex root and are unequal. But very important point here, here you see in case of a quadratic equation with real coefficient, if d is less than 0, then the roots are conjugate to each other. But in case of a quadratic equation with complex coefficient, the roots are not conjugate to each other. I will solve one question, you check. So if d not equal to 0, then it has complex roots and are unequal. Okay, I will solve one question regarding this. Write down the question: x square minus 5x 5ix. I will solve one question regarding quadratic equation with complex coefficients. The first question is, solve. Question is solve x square minus 5ix plus minus 6 equal to 0. Here you see minus 6 equal to 0. All of you see the question. Here the coefficient of x square, that is a, is 1 dear, but the coefficient of x is minus 5pi and the constant term is c. That means here you see a, b, c, b, the I have already explained you a, b, c belongs to the complex number dear here. You see how to simplify this quadratic equation. This is also a quadratic equation. So how to simplify this quadratic? Hello? Okay. I will solve one question. X square minus 5ix minus 6 equal to 0. Here you see by using the middle term factor we can solve it as a, here dear you see x square minus 2ix minus 3ix minus 6 equal to 0 dear. Here you see simply you can write this as a 6 minus 6 is equal to 0. I have already explained you x square minus 2ix minus 3ix, instead of minus 6 we can write this as a, आमे ताको लेखि परिबा कोन ना 6i square, because we know that I square which is equal to minus 1 dear. So here you see from the first two term taking out common as x, 2i minus, then the third and fourth term taking out common as minus 3i, this equal to 0. Or you can write this as a x minus 2i, x minus 3i equal to 0. So either x minus 2i equal to 0, so x equal to 2i, or x minus 3i equal to 0 dear, so x equal to 3i. So it has a two roots, but the roots are 2i and 3i, and these two roots are unequal. These two roots are unequal, but in case of a real number, if a, b, c are real, then the roots are conjugate. But here this is a complex coefficient, it has no conjugate roots. X is 2i and x is 3i. These two are the two roots. Okay. Okay, I will get any opportunity, then I will explain you more about the complex number. Thank you.
ଏହି କାର୍ଯ୍ୟକ୍ରମର ସହ ପ୍ରାୟୋଜକ ହେଲେ